Our next speaker is Nicola Moriarty from Bryden Wood. Nicola Moriarty is a director at Bryden Wood, a global company of creative technologists, designers, architects, engineers, and analysts. She is a chartered structural engineer with over 25 years experience in the construction industry, leading teams with multidisciplinary projects from conception to completion. She has a passion for DFMA and how this approach can lead to successful delivery of projects. She was involved in the early forms of DFMA in the volumetric modular approach to student accommodation and more recently on the Forge, where a combination of DFMA and other MMC approaches have been implemented on this groundbreaking commercial development for Landsec. Nicola is a keen walker and skier, along with recently developing a passion for sailing. Amazing. A hobby that lends itself nicely to her other love, which is traveling. I give you Nicola Moriarty.
Good afternoon, everybody. As Cindy said, I'm a director at Bryden Wood, and I'm here today to give you an overview of our project at Southwark, taking the platform approach to DFMA. So, first of all, what I want to just run you through is a bit of a sort of an introduction to platforms and how we see them at Bryden Wood. So, no doubt many of you are aware of the Billy bookcase that IKEA has sold for years. They took the philosophy of, instead of building a bookcase themselves and transporting a large volumetric object, it was far better to reduce it down to components. This reduced the amount of storage needed in their warehouses and made it more transportable for the end user. It's simply erected when the end user takes it home, usually erected right next to the place where they need it. Bookcase, as we know, comes in several sizes, and it's generally only small components that need to be changed to alter its size and shape. So at Bryden Wood, we're taking that same philosophy and applied it to building types. Depending on the height and clear span of what's required for a particular building, it determines the type of platform that we can use. But as you can see, there's generally lots of overlap between the system to provide flexibility. By taking this approach, we're also in alignment with the government's roadmap for 2030. And as you see, we aim to create a kit of parts that can be manufactured in high volume and high quality. But what are the benefits? So we find that we're getting less material. So the associated costs with that, the carbon, the transport, we've got fewer components. That gives us the economies of scale that we need, levels of optimization, the distributed resilient supply chains, and greater control of logistics and trading on-site activities that we're all aware of that's quite a challenge at the moment. And also we get standardised processes, so in manufacturing and assembly. So this enables us to have a diversification of the sector, so we can upskill non-construction personnel, which is very important in this market that we have, with challenges with getting the right personnel that we need. Improved health and safety, which is key. Increased productivity, reduce reliance on trades and workmanship, and promote the automation. So how does this actually apply in practice? Well, we are just currently coming to the end of our first project, really sort of pushing the boundaries on this in the Forge in London. The Forge is situated in Southwark, and it's a commercial building that we're just completing for land security. It's 2 buildings in a very, very tight site. As you can see from here, we are on the south bank, very close to Tate Modern, and as usual for anybody that knows the construction anything in London, we are bound. It's really, really close boundaries on each side with really only one access. So the kit apart and the platform approach really suited this development. Not only was the approach to DFMA led, but also design to value was a key driver too. We also had to ensure that we adhere to the requirements of the client, because they've got very, very strict design requirements that they need that actually go to their end user. We also had a planning grid that we needed to adhere to, and also had to be something that was flexible for the MEP that we're actually putting in it. So the platform approach really did allow us to really carry on with what we needed to do. So the actual system itself is the structural frame just utilises very general construction products. The steel beams are fabricated with openings to allow, the passing of surfaces to reduce structural and services zone, shear studs to allow general composite action. But then we've got steel shoes that we actually fabricated on the beams that actually sit ComFloor beams. So all that we're using is a general ComFloor lightweight decking, just in a different way, so that we've got a shutter, in effect, that we can put all the reinforcement in and just lift it into place. So there's no additional sort of bolting or fixing required on site. The downstand regulator, it's on a regular pitch, so using the ComFloor in this way, the actual floor spans are reduced. So the floor slab reinforcement is then on in mesh, which actually went up with the shuttering system. The floor slabs, we constructed them with sockets already installed, so that really sped up the MEP installation. And the MEP was roughly in 4 different modules, so really keeping the repeatability. We're an 8-storey building, so that it really sped this up, and something that once one floor was done, the operatives were just straight on to the next. It was getting quicker and quicker. So we've really had a lot of success with it. On this image, you can see that what we've tried to do is keep this kit apart. So the different colours just show the different parts that we had and just repeated them. The blue, dark blue and the light blue beams are the general fabricated beams with the holes in to allow services. The gold is just structural hollow sections for very, very narrow, but in a regular grid that was easily lifted into place. So, nothing huge, and things that the contractor, all familiar. This is, these are all construction products that we're used to every single day. So, as this was a new approach, we carried out several prototypes. Here on the left, you can see that one of the first prototypes that we did with the actual Ministry of Justice. We actually worked with them to look on their prison portfolio to see how we could speed up construction for their new rollout. We actually worked with them with some prisoners on one of their facilities to actually give them skills and to see how easy it would be to train a non-skilled workforce, which was really great. This image on the right, this is actually the forge. So this is showing you the actual shuttering tables that I mentioned earlier. What we've done here is we redesigned the shuttering that's reusable for every floor and for other buildings, but we've taken the propping back to the columns so that we're trying to speed up construction as much as possible to allow free open space along the floor plate, which is it really, really does help when you've got a lot going on and you're wanting to, bring in, especially on a tight site, bringing up in extra materials. It gives you that freedom. Here's a video of us actually doing the prototype. So these are called ridge stackers. That's lifting the confloor beams into place, as you see on the shoes. The operatives putting the propping into place. As you can see, it's very light gauge steel that we're using here, and repeatable connections, so it can be put together easy and with little instruction. These are the shutter tables going up with just the mesh on for the reinforcement. We found that actually pumping from below a wet mix was the best way to do it, to get a real nice finish. This is to using an automated screeder. On the forge we didn't, we just did it a traditional way. As you can see that, it's not taking many operatives to actually, dismantle the shuttering as well from the flooring. And again, using these ridge stackers to help them, they manipulate the shuttering as we went. So it was really quite great. So as you can see, there's a lot of wet concrete going in there. You're thinking, well, why not maybe use precast concrete? Well, we did analyse this, but you're finding that you're just transporting more volume to site, which when we drill down to it, all this, precast laid down in the yard, lifting onto another material, transporting to site, lifting to position, it just didn't make sense to us. So we didn't proceed with it. We just kept to the wet concrete in that area. The sustainability benefits is just great on this. You've got highly optimized structure, so you can reduce the quantity of building materials, which give you fewer transport movements. It has this really great knock-on effect. You're reducing your building weight, your smaller foundations. Sometimes, especially when we're building in densely populated places like London, sometimes there are actually foundations there. Reusable, you possibly able to reuse foundations, which is great. Then on the MEP, we took exactly the same approach, keeping it to as less of modules as we could, and repeat them throughout the actual building project. And with NG Bailey, using their facility, we just all off-site, so it all could be pre-commissioned to a certain stage, and that we could be, ensure that it could be just lift and fix, which was, what we ultimately wanted. The actual components, as you can see on the far left, we tried to get them so that they actually could fit into, the actual lorries that they were going to. That's another consideration, that you need to make sure that you're not doing a great massive module that you're going to need road closures for. So everything that was designed to go back in the lorry, and then that it could be stacked actually on the slabs, going back to earlier. We wanted to get as much space on the site so that we could have these deliveries made, put in place. And again, using the ridge stacker to actually lift the modules so they could be easily fixed into place. But these were actually delivered in a just-in-time logistics method, which was ideal. You don't want anything sort of stacked up on your site. And as you can see from this image, it's all very densely compact, but it's making sure that we're not only have we got all the MEP in place and it's all fixed in place, but we're also giving as much height as possible to the end user. A really sort of important aspect. When it came to the facade, exactly the same principles were taken. We looked at the elevations, and we drilled it down to about 10 elements, all componentized so they could just be picked up and installed into place. We did simulation analysis to make with the CFD to just make sure that it was going to be whatever we were going to do was going to be no overheating on the building at all. So, using all the information that we've got to just check everything all digitally. So there's been a lot of these recent months, as we've been coming sort of more into the project, we're working with the University of Cambridge. And we've had, as we know, lots of sites have webcams on. We've had lots of digital tools, and we're now analysing and how quickly, this job has gone up. The actual panels themselves have gone up in 7.5 minutes a panel, which is great. And we're also doing the analytics for the rest of the building, and also seeing, how we can sort of configure the construction process to make it quicker, and also see what went wrong, what was the hold-ups. This project was done, during the pandemic. We had, supply issues. It was definitely a major challenge, but, to say that we could, achieve that was, quite a feat. In fact, we were waiting for deliveries and some days coming from overseas. So what's the chain reaction of benefit? We're finding that there's a 30% reduction in embodied carbon on using this approach. And this is the first net zero commercial development, and we've had it certified by the UK Green Building Council, something that we're really, really proud of. And we're finding that, on this approach, there's a 13.5 increase in productivity. We know that there's lessons to be learnt on this, but it shows that it's a positive move for the industry. So, obviously, we're working with Howick, and which has been great, and we've really enjoyed it. So, but what have we been doing there? So, Howick asked Bryden Wood to actually study the feasibility of using their products in a steel portal frame building. And as part of this, we found by analysis using their sections, just use them in a different way, that we could actually go up to a 24-metre span of varying lengths, and generally in a 5.5 metre base span, which is really great. But all it is just using the product that is already out there and just thinking about it differently. I know that, speakers prior to me are just doing the same thing. It's ready, available product. It's great. It's, by doing this, you get an efficient, lightweight frame. The positive knock-on effects is, smaller foundations, which is no sort of small thing when a lot of construction projects, the money is lost in the ground. And it's also less weight for transportation costs, definitely compared to a traditional steel frame. It was just great to collaborate with Howick on this to see what we can do and take this further. So, well, thank you very much for listening to me. I hope it's given you a bit of an insight into what we're trying to do. Thank you.
Thank you, Nicola.
I have got a question. That's all
I
right.
don't know what to do now. All prepared for questions, really. Hold on. This is my moment of truth. Here you go.
Hi, I'm Sam Stacey from Innovate UK, and actually I know a lot about the Forge buildings. We sponsored it, but I was interested by your productivity figure, which is in the right direction, but actually I would have expected a greater improvement in productivity. What are your thoughts about that?
Yeah, and we would have liked it. Yeah, we would have liked it, and we are actually going through the reasons why. We're finding that we had a lot of logistics issues. There was getting products. We obviously during the pandemic we had workforce issues that was a huge challenge. So what we're trying to do at the minute is actually find sort out the wheat from the chaff. Find out, if we had a perfect or semi-perfect sort of run at it, we didn't have the supply chain issues that we had, in products, things being stocked on site, how that would have changed it. And that's looking, quite sort of positive at the moment. So we're hoping to have those figures out in the next couple of months to actually show that. So it's, yeah.
Fantastic, thank you very much. I think there's a long way to go on productivity, and I think this approach has enormous potential, but I'm sure you're preaching to the converted here. But we need to get that message out more widely as well. Thank you.
Yeah, I have a question regarding the mechanical design systems. Did the Bridon Woods did the EFMA for that system? That's a question number one. And number two, if you did it, did you have to use an MEP subcontract, an MEP contractor to assemble it? And was it tested before the assembly? So this is three questions on one thing.
Yeah, great question. So we did do quite a lot of design of the MEP to get it into a modular format. But then we did work with NG Bailey and their production facility to just see how we could even improve it. Obviously, and they did do the testing in their facility as well. So it really did help to have a collaborative approach. They did the installation as well. So to have that, and that they are we found that NG Bailey are actually one of the contractors that were actually sort of quite sort of open to doing this type of thing. So yeah, we took it to a certain part. We knew that we needed modules that could fit in the back of a truck, that we had certain floor service zone issues that we had to achieve, but it was a case of they then took it and they said, right, okay, they looked at what materials they could get, what they could procure more easily, so things like that were tweaked. But yeah, it definitely had to, I feel that it worked as a collaborative installation process.
The principal contractor.
No. So the principal contractors on this one was Mason McAlpine, and they were sort of like a construction management. Yeah.
Yeah, I think we're facing the same problem because we're building a slightly medium-sized project, and when it turns out this MEP world is a wild west and cowboys. Found it's so. Luckily, we're the principal contractor, so we actually interview people, understand what you do, what the problems are, and join our platform and software, and then we do the 100% DFMA. We do this assembly sequencing simulation, understand all the logistics, when they're coming in, the best times coming in, etc. I think that works better. But if you work with the under the principal contractor, I mean, what was the challenge to convince the principal contractor, and then at the same time you had to collaborate with other manufacturers and suppliers and installers, and they've never done this way before, and then they still prefer this old school 2D drawings, and we solve the problem on the sides anyway, that kind of stuff. How was your experience and journey?
Yeah, working with certain contractors, they still have a certain view. So to try and break down that view, you will find it tough, to say the least. But I think it's something that us as engineers, architects, the forefront of trying to push this. We've got to say to people, look, this is a good way of doing things. This is why, with what we've done in the Forge, we like to promote it because we know there's a long way to go, but we think that by showing people that, look, it can be done and it is successful. We're not bringing in any strange and wonderful products here. We're just using technology to enable things, and I think that's the main key that people have got to just embrace. It's just technology. It's just using it to help everybody. Yeah.
I think we have one more question, and that's and then you have to talk to Nicola over drinks.
Thanks. Hi, I'm Nigel Austin from Hawkins Brown, we're architects. It's a very simple one. On those diagonal props that you showed, they're removed.
Yes.
Yeah.
Okay. So what happens is it was just basically because we didn't want to put anything on the floor. We just wanted to get the next floor propped as quickly as possible. And all it meant is you're just putting your load down to the column. You've already got strength there. It's quite
instead of traditional propping, it then you aren't sterilising a floor, 2 floors. You're giving it that space, and we all know that it's challenging on site. So, yeah.
Great, thanks.
Thank you. Thank you, Nicola.
Thank you.
Well done.